What's up, you freaking geniuses? So in this video, I'm going to teach you how to determine if relations represent y as a function of x, all right? So the key thing that you want to remember with these is that each input has to be matched up with exactly one output, all right? So for instance, let's start with just a super simple example. What if I had 1 plus 1, okay? What if I said 1 plus 1 is equal to 2, and so we'll say it's sometimes equal to 2 and sometimes it's equal to 5, right? Well, that obviously doesn't make sense, right? 1 plus 1 is always equal to 2. It's never equal to 5. It can't be equal to two different things, right? So 1 plus 1 is basically the input, and then our answers are the outputs. Okay, so that's why we say that each input can only be matched up with one output. It can't be matched up with two different outputs, all right? So let's look at these two tables right here and see if they represent y as a function of x, or the output as a function of the input. So here we can see we have a bunch of different inputs, right? 1, 2, 3, 4, 5, and they all have different outputs, right? 5, 10, 15, 20, 25, all right? So since each input is matched up with a different output, here we could say that this table we'll say yes, it does represent y as a function of x, okay? Now, what about this table over here? Well, you can see we have the same input a couple times, right? We have 2, then we have 3, 4, and 5. And then, as you can see, all the outputs are different, right? 5, 10, 15, 20, 25. So, again, the same input, 2 and 2, have to have the exact same output. So here, these should either be both 5s or they should both be 10s. But we can't have a 5 and a 10. They can't be different. Okay, so here we would say no. This table does not represent y as a function of x. All right, now here is another relationship between x's inputs, domains, whatever you want to call them, and the output, the range, the y's. Okay, so again, we just want to determine if this relationship down here represents y as a function of x. Okay, so again, remember, it's called a domain here, but again, these are just the inputs, and the range, or the y's, again, those are just the outputs, all right? So remember, each input should be matched up with exactly one output. So here we can see that's the case for the first one, right? This first input is matched up with only one output, so that's fine. However, this other input, -1, is matched up with two outputs, right? And that doesn't make sense. Again, that's like saying 1 plus 2 is equal to 3 and 1 plus 2 is equal to 4. All right, so obviously that can't be the case, right? It can only be equal to one of these. So since we already failed the test right here we can say that no, this relationship does not represent y as a function of x. All right, here's two last examples that we're going to go over, and they're both, as you can see, graphs, right? So starting with one on the left over here, you can see we have 5 different points that are plotted, and if we connect the dots, you can probably already tell what this is. It kind of looks like a parabola, right? So something like that. And as you can see, all the points here are plotted. So if you want, you could turn all these points into a little table. So let's just do that real quick. What are our x, or inputs? So -2, -1, 0, 1, and 2, right? So let's just write that down here. So we have -2, -1, 0, 1, and 2. And what are their outputs? 4, 0, -1, 0, 4, right? So 4, 0, -1, and then we have 0 and 4, but we already have those written, right? 0 and 4, so we'll just leave those there, okay? So again, we want each different input to be matched up with just a single output. So here we have, first of all, -2, that's matched up with this +4. -1, that's matched up with 0. 0 is matched up with -1. +1 is matched up with 0, so we also have this going on right there. And then lastly, we have this 2 matched up with +4. +4 up there. Okay, so as you can see, this is kind of the reverse of the last couple examples, right? Because as you can see, each input is only going towards one output, right? This one's only going towards that one. This one is only going towards this one. 0 is only going towards -1. 1 is only going towards 0, right? 2 is only going towards 4. So that is all legal and legit, right? What we can't have is having a single input going to two different outputs, right? So for instance, this -2 can't go to 4 and it can't go to 0. Okay, so one way you can kind of think of this is, let's just start by giving you the output. So if I just said the output is 4, what can the inputs be? Well, we have different combinations for the inputs, right? We could say 2 plus 2. We could say 1 plus 3, right? Both of these are valid inputs and they give us the same output, right? Same thing over here. For instance, right, -2 and +2. Those both are valid inputs to this single output. Okay, but again, what we can't do is say 2 plus 2 is equal to 4 and it's also equal to 6, right? That definitely doesn't make sense. So this is a relationship that represents y as a function of x. The other way we could tell that this relationship is a function is simply by looking at the graph, right? Because with any graph, you can run something called the vertical line test, right? So if you draw a vertical line anywhere through the graph, it should only hit the graph at a single point if it is a function, okay? So for instance, if I draw a line right here, you can see it hits this parabola only at this single point right there, right? Doesn't really matter where I draw it. So if I could draw it over here, right? Another vertical point. And you can see it only hits the parabola at a single point. Okay, so those are two different ways that you can confirm that this definitely is a function. So now on the other hand, let's do this last example right here. So you can see we have, again, this graph, and this time we just have these 3 points. And now we have two ways of testing to see if this represents y as a function of x, right? So we could just take the points. So first, let's write our inputs, so our x terms. So what are they? So we have a 2, and a 2. So the only input that we have is a 2, right? That's our input. And then what are our outputs? Well, you can see they're the y's, right? So we have 2, 0, and -2, right? So we have 2, 0, and -2. So obviously here we have an issue, right? Because we get the same input, but we have 3 different outputs, right? So that obviously doesn't work. So that means this graph does not represent y as a function of x. So it's not a function. And again, the other way that we could test that is by using the vertical line test. So if we draw a line to connect all these dots, we can see that this is just a straight vertical line, right? Now, can we draw a vertical line through this line where it'll hit this line at more than one point? Yeah, obviously if we just draw a vertical line on top of it, it hits that green line at every single point. So since it hits that green line at more than one point, again, we can confirm that this is not a function. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.